Hello everyone, my name is Stephanie Hall and I am from Forest Valley Outdoor Education Center, and I'm here to demonstrate for you how to conduct a soil test with the soil test kit, which you can order through the department through Boreal. And this test comes as nearly a complete kit of everything that you will need. So 2 to 3 students per group, so you can determine how many tests that you will need for your class size. So if a class of 30, I might order 10 tests and maybe have 1 or 2 spares just in case. And it comes with everything except for a pair of scissors that you might need to cut open the capsules, a clean and sterile container to make the soil solution, distilled water, which you will need for the pH test, and a container to hold your soil sample. So you may choose to engage your students outside with quarters or perhaps trowels to select a site to sample for soil. And what I think is an interesting opportunity is to select various and different sites with varying vegetation or moisture levels, as well as, if you can access it, to get some compost to test, and you can see some of the differences of the elements and nutrients that may be available in composted soil. So today, this sample has come from our vermicompost, which is our worm compost, which has been active for a few months, 3 months, and I've just taken, about 2 or 3 tablespoons of soil for the sample. And the first thing that you're going to want to do is to make a solution. So you want 1 part of soil and 5 parts distilled water. You want to shake it vigorously and leave it for at least 30 minutes to 24 hours. And the longer you leave it, the more settled the water will be, which will mean a more clear reading when you add the water into the test. I encourage you to select the soil the day before, let it settle overnight in the classroom, and then conduct the test. So there's lots of ways to engage the students outside and making observations, making hypotheses, and thinking about making predictions about what they might find. When it comes time to actually doing the test and conducting the experiment, of course, you want to make sure that safety is number 1. You want to make sure that the students are wearing goggles and not touching their face without washing their hands for 30 seconds with soap. And we'll start off with pH. So this is a different procedure than the other 3 element tests. And so you just want to take a small amount, a small scoop of the soil. I've already preloaded it, and you want to get it up to the first line. You then want to take the pipette that is included in the test and fill to the top line. Next, each of the tests comes with a capsule, and dry hands will help you open this more easily by twisting and pulling directly over top of the site that you're going to open it to. If you have trouble opening, you can or instruct students to just simply snip the top of the capsule. So if it doesn't come off so easily, some are easier than others, or if you have any moisture on your hands, sometimes that complicates things. So you can just snip the top, aiming to get all of the chemicals into the smaller side, and mix it in. and the empty capsules can go into the garbage. So you can already see a reaction beginning to happen. So from here, you're going to close tightly and ensure that your fingers are holding this together so that there isn't any spillage when you shake. You're going to shake vigorously for about 10 seconds. And then you will let the pH test settle. And then when you're ready, when the time has passed, you'll instruct the students to compare the color of the test side of the box to the colors here. So we've got options being alkaline at 7.5, pH, 7 as neutral, pH 6.5, slightly acid, 6 acid, 5.5 acid, and 5 very acid, 4.5 very acid. So this test is designed for gardens. You can find it in most garden centers. So it is essentially working on assessing the pH level for garden plants, specifically vegetables and herbs, and then many common garden flowers. We've tried this and compared it to our pH meter that we have for our water testing kit, and it's been pretty similar. No difference has been detected. So after about a minute, you're going to want to have all of the students in their group come to a consensus on what color they think it is. So I would say getting a reading here, and then you can try and put something in behind that is white so that you can see the comparison. And because many students see colors differently or may interpret the color differently, having a few groups have a consensus on their results will help. Okay. So this is the first pH test. It goes rather quickly. The other 3 tests I have preloaded. And the pH test is really ideal for the grade 10 science curriculum. And so I have loaded the capsules already for nitrogen and potassium, and phosphorus and potassium. So the 3 distinct colors, all of the capsules match the corresponding test kit. So it's important that you make sure that the students keep those, and the color on the top of the lid is the best way to instruct students to make sure that they're matching. And so this is a little bit different in that you're not putting soil directly into the test kit, you're putting the 5-part water, 1 soil solution that you've created the day before ideally, or at least half an hour before, and let it sit. So you'll take your pipette again, and for each, you will, with aiming to try to not disturb the soil as much as you can, you're going to fill to the top line. And you'll close your capsule. The test kit. then you will close them up and you'll shake for about a minute. You want to try and encourage any of the reacting powder from the bottom. Looks good. The blue powder, for whatever reason, likes to collect on the bottom there. Okay. So then you leave the results for 10 minutes. And when you're back after 10 minutes, you will read the results. Hi everyone. We're back to read the results of our soil test. So we can begin with our nitrogen test. And the 3 elements that we're testing for are excellent conversations in what each element does for the plants. And you can see it's best to use not direct light, but daylight to illuminate the comparison bars in the chamber to the test chamber. And so if you need to, be consistent to put a piece of white paper behind, and then you can make the comparison. So for this one, I would say, it's a little bit difficult to see with the camera, that this has sufficient nitrogen. And here for potassium, I would say that the potassium here is adequate. And here, if you see that there are blue flakes, this is the only one that you can reshake and put the flakes and read the results with the flakes suspended in the water. I would say here that phosphorus is closer to deficient or adequate, and you can have multiple students decide which is closest to, and then create a consensus, of course always making notes of how the decision is made and observations of specifically what is seen. So because this test has come from a vermicompost, background knowledge tells me that this is pretty accurate. And while the worm compost is excellent in providing nutrients as nitrogen and making the nitrogen available to the plants, it is not as useful as at providing the nutrients for potassium and phosphorus, which come from other things, and you can amend soil in a variety of ways, and each in different things. So these are great inquiry questions, starting off points, and then of course endless connections to start seeds in the classroom, have conversations about growing your own food on balconies, in yards, in community gardens, etc. So there are so many curriculum connections and ways to engage the students in going outside, doing community science, collaborating, creating inquiries, and looking at plant requirements and nutrients and relating that all back to the science curriculum. So if you have any questions, please feel free to reach out and get in touch, and we're happy to support you in bringing your students outside and making science come alive. Okay, have a great day everyone. Bye.